All right, I'd like to welcome everyone to our first lesson. Our first lesson is 1.1, identifying integers and their opposites. And that's just a more complicated way of saying we're going to work on positive and negative numbers. So this is the first time you've been exposed to negative numbers. In kindergarten through fifth grade, you've worked on only positive numbers. Those are numbers that are greater than 0. They can be written with or without a positive sign. So numbers like 1, 2, 3, 4, and so on. Usually they're not written with a positive sign, but we can write it with a positive sign and it wouldn't change it at all. Negative numbers are numbers that are less than 0. So they're all these numbers that are on the other side of our number line. -1, -2, -3, and so on. And these are numbers that have to be written with a negative sign. Okay, positive numbers do not need the positive sign, but negative numbers definitely need the negative sign so that we know that they are negative. So basically, any of our numbers that are to the right of 0 are our positive numbers, where any numbers that are to the left of 0 are our negative numbers, and our negative numbers go in the same order as our positive numbers, just counting from right to left instead of from left to right. And we can use these numbers to kind of work with different types of problems that involve negative numbers, like you will see in our next slide. So example 1 says, the elevation of a location describes its height above or below sea level. Elevations that are above sea level are listed with a positive. Elevations that are below sea level are listed with a negative sign. So we have our sea level, just the level of where the ocean is. Most of your land is above sea level, but there are some few areas that are below sea level. Okay, so the ones that are below sea level, we're going to be represented with a negative sign, whereas the ones that are above sea level are going to be represented with a negative number. Okay, so our first step is to graph each location on the line. Okay, we look at our first location. Our first location is Little Butte, and it says it has elevation of 5 feet, so it's 5 feet above sea level. It's a positive number, so we mark it on our number line in the positive spot with an A for Little Butte. B is Cradle Creek, which has an elevation of -5, so it's 5 feet below sea level. Okay, so we mark that on our spot at -5. Okay, Dinosaur Valley is -9. Mesa Ridge is +8. And Juniper Trail is -3. Okay, and this just tells us how tall something is, how high it is above the ground. Okay, we have a few things that are below ground and a few spots that are above ground. Our valleys are below ground. Mountainous areas are usually above ground. Okay, part B says which point is at sea level. So we have to think about this. What would represent sea level? If our positive numbers are all of our things above sea level and our negative numbers are all of our things below sea level, the point that would make sense to represent sea level would then be 0. Because everything above it says it's above sea level, everything below it says it's below sea level, so it's that midpoint. It's at sea level. Okay, which location is closest to sea level? So we look at 0. 0 is sea level. So we're looking for the one that is the closest, so the least amount of spaces away. Well, to the right, the one that's the closest is A, Little Butte, which is 5 spaces away. The one to the left that's the closest is E, Juniper Trail, which is only 3 spaces away. 1, 2, 3. So therefore, Juniper Trail would be our location that is closest to sea level. Juniper Trail. Okay, D. Which 2 locations are the same distance from sea level? So we're looking for 2 locations that are the same distance from 0 on the number line. Okay, well, we have A, Little Butte, is 5 spaces away from 0, and we have B, Cradle Creek, which is also 5 spaces away from 0, just on the other side of the number line. So they're both 5 spaces away from 0. That means they're the 2 locations that are the same distance. So I'll just write A and B because I don't have enough space to write Little Butte and Cradle Creek, and we know A and B stand for Little Butte and Cradle Creek. Then E says which point has the least elevation. So which one is the lowest point? Remember, the bigger the negative number, that means the lower it is below sea level. So we look all the way to the left of our graph, we see that C Dinosaur Valley is our lowest elevation. Okay, and that's how just one way we can use negative numbers to kind of represent real life scenarios. And the last thing we have to cover are what are called opposites in math. Okay, two numbers are opposite if they're the same distance from zero, but on opposite or different sides of the number line. Okay, for example, 2 and -2 are opposites because they are both 2 spaces away from 0. So the number 2 is 2 spaces to the right of 0, and the -2 is 2 spaces to the left of 0. So they're both 2 spaces away, but they're on different sides. Okay, the easy way to think about it is the opposite is always either the negative or positive version of that number. So if I asked what was the opposite of -3, the answer would be 3. If I asked what the opposite of -5, it would be 5. If I ask what the opposite of 10 is, it's -10. So it's just the negative and positive version of whatever number we're working with. And 0 is the only number that is its own opposite because 0 is 0 spaces away from 0, so there is no other number on the other side of the number line. Let's take a look at our next example. It says Sandy kept track of low temperatures in her town for several weeks. Use the table to answer the following questions. So they gave us this table with the low temperatures. Temperatures can be below 0, so they're shown with negative numbers. Temperatures above 0 are shown with positive numbers. Only in really cold places do you get temperatures that are below 0 for extended periods of time. So let's look at A. It says graph the temperatures on the number line. What we have to the right is just a vertical number line. It's the same as the horizontal number line that we just did in the last problem. It's just the numbers read from bottom to top. So our negative numbers are at the bottom, our positive numbers go toward the top. Okay, so we got to graph our numbers. So week 1 was -1. Week 2 is +3. So I put my dot and I put week 2. Week 3 is -4. So I write 3. And week 4 is +2. So I'm going to do on the right side, week 4. Okay. Part B says graph the opposite number of week 3. Well, week 3 is -4. The opposite would be the number that's on the other side of the number line. -4 is on this side, which means +4 is the other number on the other side. So we have to graph +4. And then C says the temperature for week 5, which we don't have. Week 5 will go right there. Is the opposite of the temperature for week 1. What is the temperature? Well, week 1 was -1. The number that is the opposite of -1 is +1. Okay, so just another way to show how we can use opposites in real life and how we can use positives and negatives in real world scenarios. We just want to take a second now to reflect about what we did. So we have our positive numbers, which are all of our numbers that are to the right. We have our negative numbers, which are all of our numbers to the left. Positive numbers can be written with the positive sign, but don't have to be. Negative numbers must be written with the negative or the minus sign. Okay, so when we reflect, how can we graph the opposite of any number? So if we're given any number, how can we graph the opposite of that? Okay, so what we have to do is we have to count the spaces back to 0, then count that many spaces to the other side. So if I want to know what the opposite of -5 was, I graph my point at -5. I count my spaces back to 0. 1, 2, 3, 4, 5. Okay, and I go that many spaces in the other direction. 1, 2, 3, 4, 5. That tells me that the opposite of -5 is +5. Okay, that's negatives and positives. If you have any questions, please ask, leave comments, whatever you need to do.